Hello everyone. Today we'll be getting into a new lesson on law of cosines. And so we already learned about law of sines to find missing angle measures and missing side lengths in a triangle. And now we have something called law of cosines. And law of cosines also helps us find missing side lengths and angle measures in a triangle when we do not have a right triangle. So it allows us to find it for any other type of triangle, as well as right triangles. So the law of cosines tells us that if triangle ABC has side lengths A, B, and C as shown, then the following are true. We have A squared is equal to B squared plus C squared minus 2BC, and so on. And so remember, these lowercase letters are always my side lengths. And so you notice if I'm starting with A squared is equal, then the two side lengths I'm using for the rest of that equation are going to be my other two side lengths that I know. So B and C. And then remember that capital letters are your angles. And just like with law of sines and when we're finding the area of the triangle, the placement of your lowercase letter A, B, and C is very important. And so remember that the lowercase a is across from angle A. Lower side B is across from angle B. And side C is across from angle C. And so whenever we start these problems, I always encourage you to label your triangle first with A, B, and C, and then go from there. And then something to note is that the inverse sine feature on a calculator only gives angle measures from 0 to 90 degrees. So when solving triangles, always find acute angles first. So just like what we talked about before. So let's look at two examples where we are going to use the law of cosines to solve the triangle. So again, that means I need to find all the missing angle measures. And we're going to round our decimal answers to the nearest tenth. For these two examples, we're going to be given two sides and an angle. Now, it's important to note that I can't solve these right now using law of sines because with law of sines, we have, like sine of A over A equals sine of B over B and sine of C over C and so on. I don't have any where I know both the angle and the side. So like for angle B, I know angle B, but I don't know side B. And then for A and C, I don't know those angle measures. So right now I can't use law of sines. And so that's when law of cosines comes to play. So I'm going to start with labeling my sides. So I see across from angle A is side A. Across from angle C is side C. And B is already labeled. I'm going to start with finding side B. So I have B squared is equal to A squared plus C squared, because I have A and C, minus 2BC sine of B. So I can use law of cosines for this because I know my sides A and C, and I also know my angle B. So plugging in, I get that A squared is 11 squared plus 14 squared minus 2 times 11 times 14. And that should say cosine, not sine. Cosine of 34, as we see above. And then I'm going to go ahead and simplify this from here. So 11 squared, I get 121, plus 14 squared, which is 196, minus 2 times 11 times 14, which is 308. Cosine of 34. 121 plus 196, I get 317. And now that's as far as I can simplify on the right-hand side. So I'm going to go ahead and take the square root of both sides. So remember, I take the square root of b squared in order to get this to be just b. And to do this, I'm going to go ahead and head over to Desmos to type that in. And so first, since we're doing trig, I need to make sure I am in degrees. So I'm going to hit the wrench and hit degrees. And then I'm going to plug this in. So to get that square root, go here, it's this button, so I have 317 minus 308 cosine of 34. And rounding to the nearest tenth, I get that this is going to be 7.9. Okay, so now that I have my side length, I need to find my angle measures. From here, you can use law of sines or law of cosines to find your angle measures. I'm going to go ahead and use law of sines so we get more practice with that. And so now that I have side length b and I have angle b, I can use that in my proportion. I can choose either one of these to find the angle. I'm going to go ahead and use my smaller one. And so finding the angle, I know my proportion, I need to have sine of a on top. So sine of a over a is equal to sine of b over b. And again, I'm using b because I know both the angle and the side length. So sine of a over a, which is 11, is equal to sine of b, which is 34, over b, which we just found to be 7.9. Cross multiply, and I have 7.9 sine of a is equal to 11 sine of 34. And then divide both sides by 7.9. It's equal to 11 sine of 34 over 7.9. But now again, to find that angle measure, I need to take the inverse sine of both sides. And so that will get my angle measure by itself. And so I have that the measure of angle A is approximately, and heading over back to Desmos, go to functions, inverse sine, and I have 11 sine of 34 over 7.9, and I get that this angle measure is approximately 51.1 degrees. And now I just need to find measure of angle C, but since I know the measure of angle A and measure of angle B, just like what we did before, that means the measure of angle C is approximately 180 minus 34 minus 51.1. So go ahead and subtract those. So 180 minus 34, I get 146 minus 51.1, and you get 94.9 degrees. So I see the angle C ended up being an obtuse angle, so that's why it was really important that we found angle A first. Otherwise, this would not have given us that correct answer. Okay, let's try this next one. So first step, I want to go ahead and label my A, B, and C. So side A is across from angle A, side B is across from angle B, and side C is across from angle C. Just like what we did before, when we were set up in this way, I'm going to find side b first. So I have b squared is equal to a squared plus c squared minus 2bc cosine of b. A squared is 45 squared plus c squared is 43 squared. And cosine of 88. 45 squared, I get 2025. 43 squared, I get 1849. Minus 2 times 45 times 43, and I get 3870. Cosine of 88. And then 2025 plus 1849, I get 3874. So I have b squared is equal to 3874 minus 3870 cosine of 88. And now I can take the square root of both sides. And so I'm going to head back over to Desmos. So I'm just going to use what I already have typed here. So 3874 minus 3870 cosine of 88. And I get 61.1. So B is approximately 61.1. Okay, so now from here I can find my angle measures A and C, and I can use my law of cosines for that. Since I know both the side and angle for B, that is going to be part of my proportion. And so now I can just find what these angle measures are. This time I'm going to start with angle C, just to do something a little different. So I have sine of C over C is equal to sine of B over B. So I have sine of C over C, which is 43, is equal to sine of B, which is 88, over B, which we just found to be 61.1. So go ahead and pause the video. I want you to finish this problem out. When you think you have it, go ahead and press play. So the answers you should have gotten were that angle C is approximately 44.7 degrees and angle A is 47.3 degrees.